Alright, I hope you guys are staying safe. This week we're going to talk about arc length. Okay, before we talk about that, we need to talk about arc measure. So I wrote down the definition. So it says, in a circle, the degree measure of an arc is equal to the central angle that intercepts the arc. So intercept means this is our arc AB. Remember, we would write that like this. Arc AB, and C is the central angle. So that means the measurement of angle ACB is going to be 75 degrees because they're equal to the arc measure as long as it is the central angle. Okay, arc length in a circle is the length of the arc. It's a portion of the circumference. So if we look here, this is arc AB. I don't want you to be alarmed by this. This means theta, so that just means an angle. So there's two ways that we can find the length of that arc. So your arc length equals theta, or in other words, your angle measurement in degrees over 360, because a circle is 360, times 2 pi r. And we're not going to put in 3.14. We're just going to leave the pi symbol. And r, I wrote down in the bottom, is your radius. And please remember that your radius is half of your diameter. Now, there's another formula for arc length, and it's if our angle is in what we call radians. But we're not really going to go into that while we're virtually learning. But I'm going to give you the formula anyway. So you take that arc length, and it's just times that angle measurement times your radius. And that's how you get it if you want it in radians. So in your IXL, most of your homework assignment, you're just going to be plugging in things that you know. So our first example says the radius of a circle is 4 miles. What is the length of the arc? So if we look here at our picture, they gave us that arc length, which then means I know what theta is. If my arc is 55, then that means theta is 55 degrees. And so our arc length equals theta over 360 degrees times 2 pi r. So we're going to plug in what we know. Well, we know theta is 55 degrees. Divide that by 360 degrees times 2 pi, and our radius is 4. So then you get out your calculator. 55 times 2 times pi times 4 is 440 pi over 360, which reduces. So when we reduce, we're just reducing 440 over 360, which is just 11 pi over 9. You can write it like that, or you can do 11 over 9 times pi. Just make sure pi is not in our denominator. Okay, and another type of example you'll see every now and then in IXL is, can we work that equation backwards? So it says the diameter of a circle is 8 centimeters. What is the angle measurement of an arc that is pi centimeters long? So in this case, we have our arc length. We need to figure out what theta equals. So we're just going to plug in. I'm going to rewrite our formula. Arc length equals theta over 360 degrees times 2 pi r. So we also know our diameter is 8 centimeters. So that means then our radius is half of that, so 4 centimeters. So let's plug in what we know. Our arc length in this case is just pi equals, we don't know theta, times times 2 pi. But we do know our radius. That is 4. Okay, and we are just going to clean up that that right side. So this would be 8 theta pi over 360. And I'm just going to highlight theta because that's what we want to get by itself. So like anything in math, it's just a fraction. Don't overthink it. Reciprocal. 360 divided by 8 pi. In case you forgot, this is over 1, so a lot of things cancel out, and I'm going to cancel out the pi over pi. That would become 1 pi pi. The 8's over here, 360 over here, so we are just left with theta on the right equals, and if you look, we just have 360 over 8. So, well, 360 divided by 8 is just 45. And that would still technically be in degrees. So 45 degrees is our final answer.